Wishing a very good morning to our respected professors, friends, and everyone else joining us in this presentation. We, the students of Electronics and Communication Engineering Department from Technomain Salt Lake, batch of 2026, are here to present our project ShasyaSathi, an intelligent farming assistant. I am Dipshika Datta of roll number 13003222008.
Myself, Nivedita Roy, roll number 1300003222025.
Hi, I am Promit Mitra, roll number 13000322029.
Hi, I am Ankita Bhuya, roll number 13000322050. This is Group 20, presenting before you ShasyaSathi, an intelligent farming assistant. Now, I will explain our application ShasyaSathi, how it works. Our applications follows three main layers: front-end, data acquisitions, and back-end decision support, which work together to provide intelligent farming advice. First, in the front end, the farmer opens the applications. The mobile app is developed using React Native with Expo and JavaScript, which provides a simple and user-friendly interface. The farmer first selects a preferred language, English, Hindi, or Bengali. We use Expo speech so the applications can speak important information in the selected language, making it easier for farmers to use. Next, the application detects the farmer's current locations using device's GPS sensor. After detecting the locations, the app gives a voice confirmation before moving to the next step. At the same time, our data acquisitions layer collects real-time weather information using Open Weather API. It fetches data such as temperature, wind speed, and weather forecast. Both the formal locations and weather informations are then sent to the backend decision support system. The first component in the backend is the context aggregation engine. Here, all the collected data is combined and prepared for the processing. Our backend is developed using Node.js, Express.js, where PostgreSQL with Prisma ORM is used to store farmer details, crop informations, and chatbot history. The process data is then sent to the decision logic orchestras, which acts as the main controller of the system. Based on the available information, it decides which advisory modules need to be executed. The first module is the ML-assisted crop recommendations module, which uses a Python plus microservices with the random forest machine learning algorithm to recommend the most suitable crops according to the farmer's locations and weather conditions. After the farmer selects a crop, the application starts tracking the crop throughout its life cycle. If the farmer wants guidance, they can interact with our AI chatbot. For example, they can ask which fertilizer is suitable for a particular crop or how to control a specific crop. The chatbot provides a general fertilizer advice based on the selected crop and farmers' questions. For this feature, we use Grok Llama 3.3 as the language model and Grok Whisper to convert voice input into text. The system also provides cold storage advisory based on the farmer's current locations. It recommends nearby government-registered cold storage facilities. We also use Google Maps API to display the locations and provide navigations. All the recommendations from the crop recommendation module, chatbot, and cold storage module are then combined in the information synthesis engine to create one complete advisory for the farmer. Next, the translation engine converts the advisory into the farmer's selected language, so the information is easy to understand. Finally, the farmer's receives the final advisory output in the both text and voice. The voice output is generated using Expo speech, allowing farmers to listen and the recommendations instead of reading them. Overall, ShasyaSathi combines React Native with Expo for front-end, Node.js, Express.js with Prisma ORM, PostgreSQL, and database management. Python Flask with the random forest algorithm for crop recommendations, Open Weather API for weather data, and Grok Llama and Grok Whisper for the AI chatbot support, Google Maps API for location services, and Expo Speech for the voice output. Together, these technologies provides farmer the complete support from crop planning to post-harvest storage throughout a single intelligent mobile applications. Thank you.
ShasyaSathi, an app built to help Indian farmers make smart decisions about their land and crops, all in one simple voice-guided multilingual experience. Over the next few minutes, our team will walk you through how the app works and the technologies behind it. The app opens with our screen showing the ShasyaSathi logo and the tagline, Smart Farming Starts Here. This is built on our React Native and Expo frontend, which is what allows the app to run smoothly across both Android and iOS from a single code base.
वेलकम टू शास्या साथी शास्या साथी में आपका स्वागत है
শস্য সাথীতে আপনাকে স্বাগতম
प्रेस 1 फॉर इंग्लिश हिंदी के लिए 2 दबाएं
বাংলার জন্য 3 চাপুন
इंग्लिश सेलेक्टेड प्रेस कंटिन्यू टू प्रोसीड
The very first interaction a farmer has with the app is choosing a language. And did you notice? This screen speaks to the user, guiding them audibly to press 1 for English, 2 for Hindi, and 3 for Bengali. What's worth pointing out is that each of this isn't just reading out in English. Pressing 2 plays the instruction in Hindi, whereas pressing 3 in Bengali. So the farmer is actually hearing their own language from the very first screen. We built this because many of our users are more comfortable listening than. Once a language is selected, the app confirms the choice both visually and out loud before moving forward. Next is the sign up page, where the farmer registers with his or her phone number and name. Registration and login both works off the phone number alone, with no passwords required. Behind the scene, once the farmer logs in, the app generates a secured authentication token tied to that phone number. Also, the farmer stays signed up in until he chooses to log out himself.
Please wait. Location found successfully. Please wait. Location found successfully.
After signing up, the farmer is taken to the Select Your Location screen. Here, the app detects their current location automatically. It uses the device's live location together with the Google Maps API to pinpoint the farm. The farmer then names their farm, confirms the details, and gets a clear location found successfully confirmation before continuing into the app. In the navigation menu, there is a current farm option that takes the user to the saved location screen to manage farm. From here, a farmer can switch between multiple saved farms or even add an entire new farm location.
Select a farm to continue. Location found successfully. Found 3 results. Please select one. Location found successfully.
Using the manual entry option, the farmer types in an address, area, or landmark. The app doesn't require a full formal address. It works with partial inputs like location and district. It then returns a list of matching places to choose from. Once selected, the app works the same way it did with the auto detection location. The same navigation menu also displays the farmer's registered phone number for quick reference and includes a change language option. Once setup is complete, the farmer arrives to the home page, which is built around 3 simple, clearly labeled options: weather update, my crop, and storage, giving the farmer everything they need right from one screen to check conditions, manage their crop, and plan storage. The weather update feature.
Today's weather in DN block. Temperature is 29 degrees. Feels like 35 degrees. Clouds. Humidity 77%. Wind speed 6.2 meters per second. Pressure 998 hectopascals. Visibility 10.0 kilometers.
Tapping into weather update shows the current weather details for the farmer's location, along with a 5-day weather forecast powered by Open Meteor Weather API. What makes this feature stand out is that it doesn't just display the data, it reads it out loud to the farmer and seamlessly transitions between languages.
Let me start with the crop advisory module. When a farmer opens this section, the app first asks a few simple questions. Which crop are you growing? What was the start date? Farmer selects this from the calendar. Which fertilizer are you using? And if there are any problems or pest issues faced, these questions are important because based on these answers, the app gives the most accurate and personalized farming advice to that specific farmer for the specific crop. Once the farmer answers all the questions, app saves this crop record and immediately starts tracking the crop life cycle through a progress bar. The bar calculates how many days have passed since the sowing date and compares it against the expected following duration of the particular crop. When the progress reaches 100%, the app automatically shows a ready for harvest batch, telling the farmer that the crop is fully mature and harvesting can begin. The farmer then taps on the harvest crop button, enters the harvest quantity in kilograms, quintal, or ton, and confirms. The moment they confirm, the backend updates the crop status from growing to harvesting in the database and permanently saves the harvest quantity. Now coming to the machine learning crop recommendation feature. When a farmer opens the app for the first time and has not grown any crop yet, the app automatically asks, have you already shown a crop? If the answer is no, it redirects the farmer to the crop recommendation screen where our machine learning model suggests the best crop to grow. When the farmer taps what to plant, the app fetches the farm's GPS coordinates and pulls real-time environmental data from the Open Meteor app things like current temperature, humidity, soil moisture, soil temperature, and rainfall over the past 7 days. Now the model also needs soil nutrient values, nitrogen, phosphorus, potassium, and soil pH. Since these can't be directly measured from a weather API, our backend mathematically delivers them using algorithmic correlation formulas calibrated against real agriculture datasets. Once all 7 parameters are ready, they are sent to our machine learning microservice, which runs a random forest classifier trained on regional agrometeorological data, which predicts the most suitable crop for the current conditions. The top recommended crop appears prominently on the screen. The remaining crops are filtered by the current region, temperature, and humidity. So only realistic options are shown to the farmer. Our model achieves a classification accuracy of 90.5%. And even if the model is temporarily unavailable, the app falls back to a season and weather-based filter. So the farmer always gets a useful answer. This is how ShasyaSathi brings machine learning directly into the hands of every farmer.
Now, let's move to two of ShasyaSathi's most farmer-facing features, the AI chatbot and the cold storage locator. Every screen has this floating chat icon. Tapping it always opens a fresh, blank conversation. That's intentional. So each general chat session stays separate from what the farmer asked yesterday, instead of turning into one endless thread. Our chatbot actually runs in two distinct modes. The first is My Crop Chat, which opens automatically once a farmer sets up an active crop through crop advisory or crop recommendation. The second is the General Chat section, where the farmer can ask miscellaneous farming and crop related questions. This is the hamburger drawer. All conversations are saved and organized here. My crop chats and general questions, kept completely separate. Reopening any past session restores the full conversation along with its pinned crop context exactly as it was. This is the crop specific chat section. Notice the pinned card at the top, the crop name, sowing date, fertilizer, and any pest issues the farmer entered earlier. This context goes along with every question to our AI, so it already knows what exactly the farmer is growing without having to repeat themselves. The chat is also deliberately restricted. If the farmer tries asking about a completely different crop, the AI politely redirects them to the general chat section instead, keeping the advice focused. Now, this is the general chat mode. Any open-ended farming questions, be it related to pests, market prices, techniques, or anything, can be asked here. Both modes run on Grok's Llama 3.370B model with a farming-focused system prompt, so responses stay practical and farming-specific.
ধান চাষের জন্য আর্দ্র ও উষ্ণ আবহাওয়া প্রয়োজন। উত্তর ২৪ পরগনা জেলায় বর্ষাকাল ধান চাষের জন্য উপযুক্ত। এই সময়ে তাপমাত্রা ২৫ থেকে ৩৫ ডিগ্রি সেলসিয়াস হলে ধানের চাষ ভালো হয়। সেই সাথে পর্যাপ্ত বৃষ্টিপাত থাকলে ধানের ফলন বৃদ্ধি পায়।
Now, what you just saw is a feature built specifically for farmers who aren't comfortable typing, the voice input. The farmer taps the mic, speaks in Bengali, Hindi, or English, and we transcribe it using Grok's Whisper model without forcing a language parameter. So it naturally handles farmers switching languages mid-sentence. Every response has a speak button. Tap it, and the app reads the answer aloud, automatically detecting whether the specific reply is in Bengali, Hindi, or English from the text itself. So the voice always matches the actual language of the response, even if it switches mid conversation. The final, most striking feature I'll walk you through is the cold storage or warehouse finder. After harvesting, farmers often need somewhere nearby to store their produce before selling in order to prevent post harvest spoilage. We have seeded our database with 62 real warehouses across West Bengal, sourced from State Warehousing Corporation records, each with verified GPS coordinates and the specific crops that they store.
Found 6 cold storages near you.
Using the farmer's saved location, we run a haversine distance calculation directly in our PostgreSQL queries to find every warehouse within 100 kilometers, sorted nearest first. And we filter by crop so that if the farmer has just harvested rice, we only show warehouses that actually store rice, not just a wasted trip. Each result shows the name, address, contact number, and distance so the farmer can make a quick, informed decision.
FPK Agro. Distance 3.7 kilometers. Contact 9836621177. Great. Harvest removed from your list.
Together, this is what turns ShasyaSathi from just an advisory app into a genuine end-to-end companion, from sowing all the way to selling.